uh, who is eligible, what is the prerequisite, and what kind of tools I'll be covering, plus the job roles, your education background, those things we discussed on Friday. So after that, what I did was I started explaining what is DevOps. Let me summarize what is DevOps all about. See this. In DevOps, we use tools, we follow practices, and we also say a culture. So sometimes people also say DevOps is cultural shift, right? We combine all of them and we aim at releasing software changes frequently to the customers. And we don't want to lag the releases, means new software updates, enhancements, bug fixes that has to be delivered within less time. That's the main objective of DevOps. And I said practices, tools, and philosophies, right? To explain that, what I did, I started with DevOps practices. We can put DevOps definition like this also. So DevOps is combination of tools, practices, and cultural philosophies, so which aims at, which enables organizations to release software frequently and rapidly. Remember, so not just frequent and rapid, the code also should have a very good quality. So that is also important. We should make sure whatever we are releasing to the customer is highly, stable code, bug-free code. That's also important. So to start with, we started DevOps practices. I explained continuous integration, continuous delivery, continuous deployment. Now it is configuration management. See, these are all practices. If you say you are a DevOps engineer and in your project, you must be following CI, CD, configuration management, etc. See, coming to configuration management, it is used for automating the installation and configuration of softwares on hundreds of servers. So for instance, we want to install Java on 100 servers. This is automated using configuration management. Anything like that. I want to install configure Tomcat. Configuration management can simplify that. I want to deploy applications onto hundreds of servers. Again, configuration management comes into picture. Is it speeding up our process? Of course, yes. It's automating, right? So installing on 100 servers, 1,000 servers, 1,000 servers, 2,000 servers also takes same time. But if you do this operation manually, it takes lots of time. So configuration management is also used for various different use cases. Yeah, it's used for various different use cases, like network automation, security automation, deployments, patching. But remember, So every practice we adopt, it is speeding up our release activity. So in the course, I'll cover Ansible for configuration management. You'll see that. CI, CD, configuration management, containers, and yes, containers and microservices architecture. Right. So let me explain microservices architecture and not containers right now, but would like to explain microservices architecture. See this. The microservices architecture is widely adopted, widely followed architecture in today's market. Like number one, it is very, very useful. It helps in so many different ways. And it's also very essential for DevOps practice. See this, we usually have two different types of architectures. One is monolith and other one is microservice. So one is monolith and other one is. So now we are moving, otherwise industry is moving from monolith to microservices. So I could say monolith was legacy approach, old approach, and microservices architecture is modern approach. In monolith, the problems are yes, please. See, in monolith, I'll explain the challenges. Let's take one example, one application as an example. Which application you like? Shall I take Amazon? Do you know Amazon follows microservices architecture? Or Amazon uses microservices architecture? Yes. Is Amazon small application or big application? Very big application. And in Amazon, you see so many features like Prime. Prime is completely one big application. And it's a retail business, like selling online. And in retail or e-commerce, there are different subcategories: order tracking, payments, recommendations, inventory management, right? Many things come into picture. And Amazon also has Amazon Pay, Amazon Fresh. So many things are there. So ultimately, Amazon.in, it started selling books online long back, but today it's very big enterprise application. So how it works with monolithic or monolith architecture. See, monolith means, according to dictionary definition, monolith means big code base, a big rock. So let me put big code base. Dictionary meaning of monolith means very huge, big. So this entire application is packaged into one single binary. That's called monolith. So here, there are challenges. See, first challenge, adding new features. If I ask a developer to add new feature to this big system, it is time taking because the application is big and changing a piece of code, we don't know where it impacts. That may fix our current problem, but it may break other functionalities possible. So adding a new feature, even adding a small feature takes lots of time. Do you agree with this point? Yes, because code base is big. So if code base is small, adding new features take less time. So, I mean, if I give you 2000 lines of code, and if I ask you to change at line number 1500, you must understand entire 2000 lines of code. Only then you can go and make a change to that 1500 line. So it takes time. Number one, adding new features takes lots of time. Is it in favor of DevOps or against DevOps? This point, against. So DevOps says it should be fast, but it is slowing down, adding new features. It's taking more time to add new features. So which is against DevOps practice, right? Or DevOps philosophy. Number two. We should use only single technology stack. Means if Amazon application is built in Java, we should go with Java itself because it's single application. And this is one more challenge. The second problem is we have to stick to single technology stack. See, choosing a different technology stack can solve problems. Like you have Python, we have recommendations. I said, when you buy a product, it will say customer bought this product, also bought so-and-so products. Have you seen that in Amazon? You go and buy a mobile, for example. At some point, you'll see recommendations in the bottom. So that is something related to big data. So let's say Python is powerful for recommendations and Java is powerful for inventory. Correct. Now, in one place, I want to use Java and recommendations, I want to use Python. Is it possible if it is monolith? No. There is a limitation now. Number three. So in Amazon, I want to scale only such. See, generally, anybody go into Amazon.in, what they do first? Search. Search is used by everybody. Only then they will go and pick up the products and they do shopping, add to cart, checkout, make payment, all these things happen. So I want to scale only such functionality. Means I want to, you know, right, what I mean saying scale? Scale means I want to increase the performance of only such. Is it possible? No. Let's say this big application is running on 100 servers right now. I want to scale. So I want to add 20 more servers. But on 20 servers, I want to deploy only such functionality. Is it possible? No. No. You can't scale specific module. That is problem number 3. Better, I will add it to the document as well. Challenges with monolith. Number 1, adding and enhancing features take lots of time. First problem. Second problem, we can't use multiple technology stack. Number 3, you can't scale specific functionality or module. And if this one application goes down, entire system goes down. Got the point? If I deploy Amazon as a single application, if that single application is down, the entire application is down. These are the challenges. Even other challenges I can highlight. For example, bringing in a new person into the team. So if I bring a new person into the team, he takes 3 to 4 months to understand the system before adding value to the system. And bringing new members to the team, it takes 3-4 months to understand the existing system. Challenges, okay? So to overcome all those challenges, microservices architecture is the solution. So if we use microservices architecture, see, first of all, what is microservices architecture? See, microservices architecture is a approach where one big application is divided into smaller services. In microservices architecture, we break one big application into smaller service called microservice. Right now, see, each service is treated as an application. So Amazon.in here, you may see Audible. Audible is a feature where they sell audiobooks. If you want to read books and listening, Audible means listening, right? That's one application. So Audible can be a microservice, or even in that Audible, we can have multiple microservices. Coupons, separate microservice. Prime, different one. Books, right? Bestseller, fresh, many things, orders, cart, payments. So behind the scenes, everything is one micro service. So if Audible is down, can I still use my Amazon? Yes, I can use. If only recommendations engine is down, can I still go and shop? Yes, I can buy it. Maybe I won't get recommendations, but other things I can still do. So that's the advantage. That's one advantage of microservice. Now, we can use multiple technology stack. For recommendations, I want to use Python. Of course, I can do that. For inventory, I want to use Java. Yes, I can. For search, I want to use Elasticsearch and Python again. Yes. For each and every service, it is a separate code base, separate application. It runs on a separate server. Obviously, we have flexibility to choose different technology stack. And can I scale a specific module? I want to scale only search. I want to scale only payments. I want to scale only Audible. I can scale that. If one or more services are down, otherwise one or two services are down, still customers can use the application. If recommendations engine is down, that won't stop customers to use the application. They can still go search, find, check out, make a payment, get the item. How about adding new features? Takes less time. Why? So if I ask you, hey, go and make a change to Audible application, you're not going to think about entire application. You're going to only think about Audible. So Audible may be a small application, right? And working on that small application will not take much time, right? Obviously, adding new features takes less time. So these are the advantages of having microservices architecture. See, we can add features fast. Is it against DevOps practice? Or it is in favor of DevOps practice? It's in favor. And see, downtime also one of the DevOps responsibility. So making sure the applications are available, there's no service outages. These things are also part of DevOps, right? You understand, right? What is microservice and how it is aiding DevOps principles or philosophies. We can add more also, like infrastructure as code, but that becomes cloud specific things. But still, those points are valid for DevOps. So what I do, I leave these things now. So when someone asks you what are DevOps practices you must follow, continuous integration, continuous deployment, delivery, configuration management, containers and microservices architecture. What else? Sorry, I want to add a few more points. Monitoring and log management, of course, that's also important. So after you release changes to production, you must monitor the servers. Only then you can avoid downtime. Right? To prevent failures and system outages, we must have robust monitoring in place, monitoring and log management in place. See the note I want to give. So the projects I worked with, almost all the projects I worked with, except one project, we had a separate monitoring and log management team. Except one project. All of my other projects had separate monitoring and log management team. See, sir, this is my experience. I'm not saying this is industry standard, but so in one project, I personally did the setup of monitoring tools and creating dashboards, configuring alerts, those things I did. But in other projects, right, we used to have a separate team, and anything related to monitoring, we used to talk to that team and collaborate with them for getting our tasks done. Any questions on this log management and monitoring?
Will you explain it clear, sir?
Which one?
Monitoring and log management.
Okay, fine. So what is monitoring basically? Maybe that's your question now.
Yes, sir.
Yeah, let's take this. So I'm running my application like this. This is my production environment. In production environment, I have something like this. I have load balancer and I have Linux servers running my application. I'm just taking monolith as an example. One single application I'm showing here. So my application is running on 3 servers and the application has a DB. So the code running on these servers, they connect with DB. Right? So customers access this application. Monitoring means I monitor how the CPU utilization is. If CPU utilization becomes 100%, server will crash. I should monitor CPU utilization. And I should monitor network performance. How the traffic is coming, how speed the request is processed, and how quick the response is going out. So I need to monitor network. Number 3, I should monitor my memory utilization, means RAM. Plus, I also should monitor the disk usage. If disk becomes full, system crashes. If memory becomes full, again, system crashes. Network performances are there. System may not crash, but customers experience latency, slowness. So if CPU is high, again, system can crash. So we need to constantly monitor these metrics so that we can make sure we're not getting into a trouble. If CPU is high, maybe we may go and add one more server, or we may increase the CPU of the existing servers. If disk is becoming full, maybe we will remove unwanted files, we archive them. These things we will take. So likewise, we monitor the servers of depth and servers of DB. Even we monitor the load balancer. So monitoring is that. So why are we monitoring? To make sure we're not letting the systems to crash, right? And log management. So I'm a user, and this is a banking application. I used online banking portal, and I made a transaction of 1 lakh. The transaction got failed, but the amount is debited. Amount is debited, but transaction failed. That's why I'm sending 1 lakh to you. From my account, it's gone, but you didn't receive it. It is a failure transaction. If such failures occur, we log them. Log means we write that exception to a file, that is called logging. So likewise, not only exceptions, we also log the information. We log warnings, we log errors, we log all useful data, and that useful data is logged into a file. And using tools like Splunk, we deploy agents. These agents collects those logs, and these agents will push logs to some central location. Likewise, your metrics also. There is Jabix, Grafana, Prometheus, Gray logs. There are different monitoring tools in the market. Using that, we send metrics. In that application, we can monitor, we can configure alerts, those things we can do. So coming to log management, the information, warning, exceptions, all that gets logged into the disk by default. That is done by the development team, and those logs will go into one central location like Splunk. So if there is, like I said, I made a transaction of 1 lakh, it's failed. Money is debited from my account, but the transaction didn't complete successfully. And the entry will be there in the Splunk. In the Splunk, that failed, the stack trace of that exception will be in the Splunk. So now bank support team may be using this Splunk to find are there any exceptions, and based on those exceptions, they resolve them. So let's say my exception is found in this Splunk. They'll take that exception, they'll see from which account number to which account number, what was the exact exception, those things. So when such exceptions occur, right, they fix, and my 1 lakh will come back to my account. So that these things they should do. So that is done with log management. Or, so there is one functionality in my application, that is download Excel file. When I click, I'm not downloading that. So there is some exception in the background. So exceptions are nothing but logs. All exceptions will be stored in logs, and through logs, we find them, we troubleshoot them, and we fix them. So that's about monitoring and log management.
Yes, sir, I understood. Thanks to
No problem. Right, now let's understand DevOps philosophies and culture. We understand DevOps practices. Now we will see DevOps philosophies and culture. Number one, don't work in silos. Silos means no collaboration individually. If I am a developer, you are a test engineer, and if I work in silos, means I never speak to you. I never communicate with you. I never collaborate with you, right? That is called silos. Don't work in silos. Means dev, test, operations, everybody, they are physically different teams, but virtually they should work as a single team. communication and collaboration is the key. Yes. I may need some data from you, or you may need some information from me. Obviously, I should know you have that information, and you should know I have the information you need, and we should be in a position to communicate. You can ping me on my communicator saying, hey, Hari, I want so-and-so thing. Or I can ping you, hey, I want so-and-so information. Or there may be something I should go and configure, and you have to collaborate with me. So such things are very, very important in DevOps. So if you ask me personally, many people fail here. Many people fail in this communication and collaboration. Yeah, that's very important. And you must be proactive. You should, generally what happens, people like you, like freshers getting into this DevOps jobs, what happens generally? Well, let's say you got a job after finishing a course. You join a project. The project, your lead or someone will talk to you. He will give a task. And you people, what generally do is, you will not ask questions. If I say do this, probably I'm not giving you 100% of information, or I gave 100% of information, but you still have some doubts. So generally what happens, you hesitate, assuming if I ask this question, I don't know what happens. So because of that, because of that fear, you people won't ask more questions, and you spend 2 days and 3 days. After 3 days, they'll ask you what happened to the task. And if you say, I didn't understand this, and they will not be happy with you. Why? Because you must communicate with them at the right time, right? Otherwise, second scenario, you gave me a task. Let's say you are my manager or lead, you gave me a task, and the task you gave me requires the involvement of log management team, for example. There's a Splunk team, and I should closely work with them to finish this task. And I will ping Splunk team, hey, I have something to discuss with you. And they will say, yeah, we will discuss. And let's say they keep postponing for 1 day, or 2 days, or 3 days. And after 3 days, you lost me. What happened? I will say, Splunk team, I couldn't catch them. I couldn't get information from them. Is this a mistake of Splunk team, or is this a mistake of myself? It's mistake of myself. It's my job to connect with Splunk team on time and get what I need from them on time and finish my task. So in this case, my task completion depends on other teams. So obviously it is my problem. What managers will say, how did you communicate? I'll say I pinged him, they're not responding. So when you're pinging them on communicator and they're not responding, what is the best approach is set up a meeting in your Outlook or somewhere. Go create a meeting, put the title, why this meeting is, and include that Splunk team, include your manager, or include your leads, and just set up a meeting. Even if they're not responding, then it is their problem. So when your manager or lead in the loop, right? And the Splunk team will obviously respond. When you do one-on-one communication, they usually avoid, maybe they're busy with something else. They will not avoid intentionally. So they will be focusing on their things, right? Obviously, and like you're focusing on your things. So these are the techniques and practices we should follow in real time. So if you are not good at this, and you may face problems. See, when I say communication means conveying what I want to convey and understanding what the other person is conveying. So here I'm not talking about English grammar, fluency, vocabulary, nothing. I'm just talking about how to tell him what you need and how to understand what he is saying. That is communication. And collaboration means there's a task. Now, two people should work on that task. That is called collaboration. Yes, automate manual repetitive tasks. So don't work in silos. That's a culture. You should not work in silos. So I mean, virtually you should behave like all of them are in your own team. And you also should know the right people, and you must know from where to get the information you need. I missed one point. I couldn't recall that. But that's okay. When I recall it, I will give that fourth point for you. This is perfectly fine now. We know tools, we know practices, we know culture and philosophies. So we need to combine all of them to achieve or implement DevOps. Right. Then, see, to better understand the concepts of DevOps, I would like to introduce this one. DevOps key performance indicators. So I mean to say the key performance indicators will help us to measure DevOps success. So based on what we measure, that gives better clarity on what is DevOps again. So even though I gave definition, I talked about practices, philosophies, tools. So addressing key performance indicators will give you better knowledge on why we are doing DevOps. So DevOps KPIs, we call them KPIs. DevOps key performance indicators. These are the metrics we measure. Number one is lead time. So lead time talks about the time taken for a change to release into production. Means, let's say your lead time is 1 week. Means what? You take 1 week to release new features into production. For example, you take 5 working days to release new features, then your lead time is 5 days. If your lead time is 6 months, is it good metric for you? No. So lead time should be always less. If your lead time is 1 year or 6 months, that is old approach. The second metric we measure is mean time to recover. See, 1 second. Let's say your current lead time is 3 months. What will you do? Will you try to reduce it? Obviously, right? I mean to say, if CPU is high, what you do? You try to reduce it. If disk is full, again, you try to make some space available on the disk. Likewise, if lead time is high, obviously you must reduce it. So mean time to recovery means if any failure occurs, systems may go down. So the amount of time we take to bring back the systems is called mean time to recovery. The time taken to bring back the application from outage is called mean time to recovery. If your application takes 6 hours to come online, if any crash happens, that is high. Depends again. For some applications, 6 hours may not be a significant value. For some applications, 6 minutes also can be a significant value. Like applications, Facebook, Gmail, not Gmail. Gmail, I think they make less revenue. They do make revenue. Don't forget about that. Gmail also, they make revenue. Google makes lots of revenue. Ads, YouTube makes lots of revenue. If YouTube is down for 30 minutes, what happens? Lot of loss, right? So for 30 minutes, Google couldn't play the ads, and obviously Google couldn't charge from the customers who are playing their ads. Obviously, it is significant. But if Java Home website is down for 1 day also, I will not lose much money, right? So right now, we're not selling any online videos, right? If Java Home also selling online videos where visitors come, they check the preview videos and they say buy, they pay some money. If Java Home website is something like that where we make money, so obviously 30 minutes also a significant loss for Java Home. So the second key performance indicator for DevOps is mean time to recovery. And third one is deployment frequency. This measures how often we make deployments. Means we built 4 features and we want to deploy that. Or we built 10 features, we want to deploy that. For example, we deploy every week and deployment frequency is weekly. And let's say we deploy every 6 months and deployment frequency is 6 months. But according to DevOps, 6 months is too much. According to DevOps, it should be like weeks, or sometimes it also could be days. Like standard average deployments will be a release every 2 weeks. So nowadays, right, it's a 2 weeks release or 3 weeks release average. So we will continue this, but before closing today's session, I want to collect numbers of online attendees. Let me see if there is a way I can capture this. This is not a real quiz. I'm trying to. All online, you must have got a pop-up. I need your name followed by number, please. Did you get a pop-up? Yeah, please type your name and phone numbers. Somasundar, not in the chat window. There's a pop-up. Can you enter there? No, don't type in the chat, please. Only 15% of, sorry, 55% of participants entered. Others, please. Fast. Go ahead, pick. All of you, please. Yeah. Online, did you finish? 7 more people to enter. Fine, thank you. See you tomorrow. Thank you online. See you tomorrow.
Hello, sir.
Yeah.
Sir, on Friday, I joined at last, sir. I didn't listen properly.
Friday?
I joined in 9:50, I think.
Okay.
That CICD, na? I didn't listen that one.